Welcome back. As you know, I am Eli, the computer guy, and today we're going to answer the question of whether or not you need to be good at math to be a technology professional. And the answer is no. There we go, end of video. Anyways, I think this is actually a very interesting question because this is one of the problems that we have with people that are trying to get into the tech industry. You know how I bring up that example of when I ask people what they want to do in the tech industry and they say computers, right? Because they have no idea what the technology industry is. They have no idea what the hell we actually do. And so therefore, they think there are requirements on becoming a professional that simply do not exist. So I do one-on-one meetings. If you don't know, you can go to elithecomputerguy.com. There's a little link over on the right-hand side that allows you to set up an appointment. And I do one-on-one meetings with people here in Asheville, North Carolina to talk about their career and their businesses and basically how to get ahead and those types of things. So I was doing one of those meetings a couple of days ago, and one of the interesting things is this person is really interested in becoming a technology professional. They're just really not good at math. Like, really not good at math. But anyways, right? And the interesting thing is they're going through and they're trying to get their degree in computer science or computer engineering. And they have these issues basically getting through the math curricula. And they're like, Eli, I so want to be a technology professional, but what can I do about my problems with math? And I looked at them and was like, well, do you actually need math for what you are trying to do? And then they looked at me like a little bit confused. And they were like, well, but I want to do technology. Eli, I want to do computers, so I need to know math. And it's like, really? Really? When I went through college, just to be clear, when I went through college, again, I got my degree in criminal justice. I had to do one or three credits in math. And so I did like statistics for social sciences. And to be clear, I barely passed that class. I barely passed that class. And yet, hey, look, I've been a tech professional for a long time. Because the reality is that you don't actually need math. And more importantly, you may not need a lot of the requirements that you're assuming that you need. One of the problems that we have in our industry is many people don't really, again, truly do not understand what we do. Not only it's the students don't understand what we do, their parents don't understand what we do, the politicians don't understand what we do. Even the professors, you may be going through a computer science program frankly, with a professor that's kind of clueless, right? They got their PhD 20 years ago, and they've been teaching Java ever since, right? And so one of the big issues that you run into is you may think or you may have been told that there were requirements for this industry that simply do not exist. And so you may be beating your head against a wall trying to fulfill requirements that nobody is gonna give a damn about once you get into the real world. And if you stop focusing on the crap nobody cares about and start focusing on the stuff that people do care about, that is probably I would argue, going to do a lot better for your career. Now, if you're sitting there and you're thinking about getting a college degree, it's important, more or less, there are three tracks you can go down to get a bachelor's degree in the computer world, right? Now, if you go to Stanford, if you go to any place that's more focused on technology curriculum, they may have many more different types of degree programs, but in general, if you're going to be going to a state school here in the United States, you're going to have computer science, you're going to have engineering, and you're either going to have IT for information technology or IS for information systems, and more or less horseshoes and hand grenades, basically the same thing. So I want to talk about these different degrees that you can get and talk about where that is going to lead you in the path for your career. Now, the first degree every aspiring technology professional thinks that they need to get is computer science. Eli, I really want to be smart with technology. I really want to be smart with computers. So therefore, I'm going to get a degree in computer science. And it's always funny when people get into computer science programs when they start losing their minds because they think, oh my God, this is hard. Holy crap, who knew? Technology is hard. And the reason is because they focus on the first word in computer science and basically ignore the second word in computer science. So when you go into a computer science program, you are going to be going into a science program that is focused on computers, right? So again, if you went into a biology science program, you know that's science, right? If you go into a physics science program, you know that's science. But for some reason, when you go into a computer science program, people think you're going to be learning about, switches and routers and I don't know, storage systems and that type of thing. And that's just not really what computer science is focused on. So when you sit there and you sit down and you're sitting at a computer, you're used to dealing with a full-fledged product, a Mac, a Raspberry Pi, an Arduino. This is the full-fledged product. Now that product is built with components. It's built with, CPUs and RAM, has an operating system on there, the whole nine yards. Again, those are still products that then come together for that finished product. What you have to be thinking about is if you get a computer science degree, what that degree is really focused on is it's focused on teaching you the lowest level skills that you need to actually be able to build systems. And when I talk about build systems, I'm talking about going down to the kernel level of the operating system, doing device drivers, that type of thing. So I think about this when I went through the MySQL class. So I don't know, 16, 17 years ago, back when MySQL was still owned by MySQL before it got bought by Sun and Oracle and all that disaster happened. Anyways, I went to the MySQL class in Washington, D.C. to learn structured query language. Anyways, the interesting thing, so we're sitting there, right, and we're learning how to do SQL, and we're learning how to use back-end programming languages, back then PHP, in order to interact with SQL, and that's what we were doing, right? And so that's kind of like coding, and that's what most people think about, right? When they think about being a technology professional, it's like, oh, SQL, oh, PHP, or Python, or Ruby on Rails, or Node.js. That's kind of what they're thinking about. But what you have to consider with computer science is I went and I was talking to the instructor, and so back then, the whole idea of open source was still a pretty new concept. The idea of you give away the product and then you charge for consulting services or whatever else, that was a newish idea back then. So I went and I talked to the instructor, as I do. I talk with everybody. I was like, yeah, how does this work? And he said, well, actually, it works really well. So we was talking. I think it was Travelocity. Don't quote me on that, but I think it was Travelocity at that time. And so Travelocity had decided to use MySQL clusters of servers as their backend database system. They were using Linux in order to deliver the MySQL services. And basically, what Travelocity had done is they had gone to MySQL to pay for engineering services so that the engineers at MySQL could go into the Linux kernel and literally make the kernel in Linux run more efficiently for MySQL. So whenever you're dealing with an operating system, right, operating systems many times are like general use operating systems. They're good for running database servers and Nginx and a web browser and playing video games, right? Well, the thing is, when you can do everything, decently, you don't do anything awesomely. And so basically what Travelocity was asking for is, hey, we just want clusters of MySQL servers. We don't want the rest of this horse crap. So let's strip out, let's take a distro of Linux, strip out all the stuff that we don't care about. We only care about MySQL for our clusters, and then go into the kernel itself, to optimize to be able to get the best speed and the best efficiency out of all those different hosts within the cluster, right? And so that is what computer science is about. Computer science is about things like optimizing the kernel. Computer science is about things like making sure the device drivers work how they're supposed to be working. Computer science is actually science, even when you're dealing with video games, right? Why math is important for computer science is like when you play a video game. I'm playing Prince of Persia right now, right? And I hit all these buttons, and my character, does stuff. And the other characters do things, right? But there's all this crap zigzagging across the screen. Well, somebody has to do the math. somebody actually has to do the math to make sure that when you launch an arrow from here, it's going to lose X amount of height over X amount of distance. And then if the person that you're fighting does something, then that will hit the arrow that you sent and it will go in a particular direction. There is a lot of math that goes into that type of thing because, again, it is a mathematical equation that people have to figure out. And so when you're thinking about computer science, yes, math is going to be incredibly important because you're going to be taking a program in computer science. It's a science program, and therefore, again, to do many of the things that you need to do with computers, understanding high-level math actually is a very important thing. But the question you got to ask yourself there again is, do you want to be screwing with the kernel or do you want to be building the next Facebook? Then we get to computer engineering. So computer engineering is a really cool sounding degree program that I think a lot of well-intentioned people get into and then regret their decision. Sounds great on paper. Oh my God, on paper, it's computer and engineering. That's gonna be awesome. Yeah, and until you get the math classes. You get the math classes, right? So when we talk about computer engineering, basically this is the intersection between the computers and the hardware. So again, when I talk about Arduinos, when I talk about Raspberry Pis, those types of things, remember there are people out there that actually have to design the hardware in order to work with the systems, whether, how ARM processors are going to interact with RAM, that type of thing. And so when you look at computer engineering is engineering of computers. Again, when you look at Arduinos, when you look at Raspberry Pis, that's the type of thing, that's the product of computer engineering. So you need to understand code, and you also need to understand, energy engineering, things like thermodynamics, electricity, all of that kind of stuff. So again, in that particular world, you're also gonna need to know math, right? Because again, if you have just an insanely complicated circuit, and you have voltages, and you have current, and you have a whole bunch of stuff going on, you're going to have to be able to calculate exactly what's going on there to make sure that you don't either fry certain components or that you actually give enough electricity to the components that actually need it at the end of the day. And again, that's where you think about things like thermal issues, so heat issues. Basically, how much heat can this component take for how much time before there's an amount of degradation, and therefore if you do a whole big math equation, you can figure out the optimum heat level for that particular component. And so when you go into computer engineering, again, you're going into engineering. Now again, if you have a mechanical engineer or a structural engineer, if you said, or if you asked whether or not somebody who is designing bridges needs to know math, well, obviously they do. Again, you need to understand structural forces and all that kind of stuff. It's very important. And the same kind of thing is true with computers. Yes, it's not as big as a bridge, but it is. It's very complicated engineering. And so you're going to need to know high-level math in order to be able to do the work in that world. So again, with computer engineering, that's what you're going to do. But again, it goes back to the question, is that what you really want to do? Do you want to invent or create Raspberry Pis, or do you want to use the Raspberry Pis that already exist? And that's where you get into degree programs with either IT or IS, information technology or information systems. And basically, this is a degree program where you're going to be learning how to use products that already exist, right? So this is the type of program where you'll be learning database systems that already exist. You're not dealing with the kernel, you're dealing with the SQL and the clustering and that type of thing. You're dealing with programming languages that already exist. You're dealing with hardware that already exists. Basically, what information technology or information systems does is we go out, we find the products that already exist, and then we assemble those into infrastructure to provide the services that our customers or our bosses need, right? Again, I'm working with this this project right now using a Blues IoT modem. And so everything that all the components that I'm using have already been created by somebody else, right? So I have Python. So on my main computer, I have Python that runs something called the Bottle web app framework for Python. So basically, you run Bottle, and it presents you with a nice little web app on your computer. That's interacting with the API that Blues has created. That then sends information down to a Blues modem, piece of hardware that's connected to my Raspberry Pi. That's then connected to a screen, and then on the Raspberry Pi, I also have Python running. And that is able to grab the information that comes in from that modem, parse it, turn it into something that's human readable, and then print it out on the screen. Right, that is the kind of system that I'm creating. Again, back when I had my managed service provider company, we would go in and we would sell networking equipment, routers, switches, set up VPNs, Active Directory, all of that kind of stuff, right? We are using products that already exist and assembling them into an overall infrastructure to actually provide a solution to the problems that our customers are having. And so in the IT world, here's the thing. You don't generally need to know a hell of a lot of math. Right? When you're plugging in, the networking cable into switches, as long as you know, this one goes into port 1 and this one goes into port 2, you're pretty good. Sometimes you have to do a little bit of math. Again, the difference between bits and bytes, especially when you start talking about speeds and things, can be a pain in the ass. But, we all kind of lie about that one. We're all like, yeah, that's probably what the number actually is. Who knows, right? But again, like when you really think about it, and even in the coding world, so a lot of degree programs nowadays, they're not necessarily going to teach you about routers and switches anymore because that's not as valuable as it used to be. But they're going to teach you about programming languages. For some reason, Java. Again, I've actually heard this from professional coders where they're still frustrated how much Java is used in the academic environment because almost none of them actually use Java anymore. But anyways, right, you're going to use Java. Java is already a full-fledged programming language that you're going to use. Java, you don't think about it, but Java is actually a product that you're going to use. They're going to show you how to use database systems, whether it's MySQL or MariaDB or Oracle or MS SQL or one of the NoSQL things. They're going to show you how to interact with that particular product. For resiliency and data recovery, they're going to show you how to use particular products. And at the end of the day, again, in the ITIS world, there is some math that you have to do, but it's very kind of back of the napkin. That the kind of thing like if you're throwing up, 100 surveillance cameras and they're streaming at 1080p that requires 3 megabit per second footprint, and then you have to start okay, well, let's see here, 100 cameras times 3 megabits per second means I need a gig switch. Or I need to put intelligence to the edge because my 100 megabit switch is going to crash, right? That's the kind of math that we're going to be doing, at least in the ITIS world. You don't have to do advanced things because you're not designing video games. You're not getting anywhere near that damn kernel. You're not dealing with device drivers. You're not really dealing with much thermal properties, right? Basically, your thermal issues is you see that your CPU is running at 80% and you go, "Oh, get a better heat sink." Right? Like if my CPU is running at 80 degrees Celsius, the answer is bigger damn heatsink or better airflow. I'm not sitting there going, well, maybe if I made this chip out of XYZ and then the heat dissipation property would be X to the Y. I don't do that crap. It's like, okay, I have small heat sink on chip and it's at 80 degrees Celsius. I buy bigger one. Ugh. Okay, it's at 50 degrees Celsius. Woo-hoo, that's math. I need bigger. That's basically the math that we do. I need bigger. Oh, that one's not big enough. Oh, that one's too big. That's basically the math. And so that's something that you need to be thinking about is what are you really going to be doing? What problems are you actually going to be solving And so, therefore, what skills do you need to solve those problems? Now, in this world, slightly adjacent, but I'll just talk about it for a minute because it's, close enough, is basically like the coding boot camps, or if you want to learn how to code, right? You're thinking, okay, I want to learn Python, or I want to learn Node. Node, everybody needs to know Node. Or Rust. Rust is the cool, sexy one right now. Yeah, those Node people better go hide. Rust is in town. And so, again, a lot of people are thinking, it's like, well, Eli's talking about switches and database, but I want to be a coder. So I need to know math too. All right. And again, the answer comes back to not really. I mean, unless the products you want to design are math focused, right? So if you're creating programs that are going to do like financial planning, right? So you got to understand statistics, that type of thing. Then you might need to know math. Again, if you want to create games and you're going to use like physics engines, or basically you're going to have physics in there. So if you push on a ball and it goes up, but there's wind coming from down, like you may have to actually know math for that particular type of thing. Other science stuff, there might be some things out there where you need to actually know math. But think about that for a second, right? Basically, think about what I'm saying. I'm saying you learn programming, you learn Python, Node, Java, whatever else. And then based off of what problems you're trying to solve for, the problems that you're trying to solve for may require that you understand math, but the coding component doesn't. Again, a lot of the projects that you're going to be dealing with, you're going to be dealing with API calls, right? The big the big phrase that I've been using for the past year is AI is hard, APIs are not. So again, that's one of the things people get confused about. They're like, well, what about AI, Eli? Eli, I'm going to put AI in my coding projects, so therefore I've got to go know math. It's like, no, no. You have to understand how to make an API call. When you interact with um, OpenAI's API, it's about 10 lines of code. Right? You create the little connection with your API key. You create the request with a couple of things in there. You parse the response that comes back from the request, and that's it. Now, do the people that work for OpenAI, are they amazingly smart? Yes. Do the people that design ChatGPT and the OpenAI's systems, do they need to be really good at math? Yes. Do I need to be good at math to make a request of an API and get a response back? Absolutely not, right? Even though math is occurring, math might be theoretically in the room, doesn't mean that you actually have to interact with it. Again, it's interesting with, again, we talk about things like APIs. There's so many like hardware APIs now in this modern world where if you want to get the geolocation, right? So back in the day, if you're going to try to get the geolocation of the device, you would have to triangulate off of like different like cell phone towers or whatever, and you'd have to figure out the time it takes, the signal from one tower to get to your device, and the signal from another tower, and the signal from another tower, and then you have to do this very fancy math to figure out where that means you are. Do you know how you get geolocation now? It's called there's a HTML5, a JavaScript APIs. Basically, you call the geolocation API. In JavaScript, it's like give me location of device, and it's like here's the location of your device. You're like thank you, right? So again, is there the whole GPS, right? But what if you're simply coding? What you're interacting with is simply an API call. Again, I think about this with things like computer vision, right? I really like OpenCV. We're going to be doing more projects on the main channel when it comes to like AI and like on-device AI. But again, even with that, the people that created OpenCV, incredibly smart. They needed to understand a lot about math. What they created with their math skills is amazing. For me, I use a bit of Python. I call very specific functions, and basically basically what my function looks like is here's what is it called? Here's a template or whatever. Here is the cascade filter. Here is the cascade filter with like a whole bunch of numbers I don't understand. Here is an image. Does anything in that image is that represented in the cascade filter? If so, draw a square around it. Right. So again, faces. So basically, what you can do for image recognition is you train your robot or your computer on the image. And what that is you take a whole bunch of images, you run it into their system, and basically you sit there for the next hour literally drawing squares around things. So when you train OpenCV, you give it the images with the whatever is in there, and then basically you draw squares around the image or the item that you're trying to track. Then you do another line of code that basically says, here are the positive images, here are negative images, and basically train, and it'll go through and it'll train, and that's what you do as an ITIS professional. And then it comes out with this thing called a cascade filter, which is just a whole bunch of numbers. God knows what the hell it actually means. And then basically within the Python script, you feed the cascade filter, you feed the image you want analyzed, and then basically say, does this image have anything represented in this cascade filter? If so, give me the XY coordinates, and then I draw a little box around the XY coordinate, and you see how well the computer quote unquote sees, right? Designing OpenCV, wow, you gotta be smart to do that. Using OpenCV, not so much. Not so much. So anyways, those are some of the things to be thinking about with this whole idea of, do I need math to do computers? So anyways, that is a long-winded version of, no, you probably don't need to be very good at math to do whatever it is that you're doing, unless you actually want to truly build AI or do that type of thing. Even when you go and you look at things like Tesla engineers, what's really interesting is many of them are using products, again, that have already been created. Again, they need to know a lot of stuff. They need to be highly qualified, but the math skills that are required are probably not nearly what you think it is, even for much, much higher level things that you think about. Again, things like autonomous vehicles and that type of thing, depending on what you're doing. Again, what your job task is, you may not need to know nearly as much math as you think you do. Again, I bring up this whole thing of computers, and I know for some new people out there, you might get frustrated that I'm laughing at you, because I am. The good part about doing this stuff for 20 some odd years is you get to laugh at the noobs. That's one of the rewards. And one of the rewards of dealing with the pain of this industry is laughing at the new people. But the reason I bring up that whole computers thing is I did that in an interview. One of my first interviews that I did with a startup company, a very good startup company in Baltimore. I went in and the guy was like, what do you want to do? And I said, computers, right? I had already done military electronics. I was already halfway through my MCSE. But even then, I still didn't really grasp this whole concept of, no, seriously, what are you doing? So I said, computers. And then that interview did not go well. Literally at the end of the interview, I knew it didn't go well. So I was like, hey, just out of curiosity, how well did that interview go? And he said, not well. And it was like, okay. And basically I learned, never say computers. Again, it is better to make up something that sounds impressive than to say computers. But that's one of the big issues, right? I get that with people. Like, Eli, should I do networking or coding? Like, those are two entirely different worlds, even in networking nowadays. When you talk about networking, again, I talk about these IoT modems, right? You have IoT modems, you have 5G, you have these towers, you have fiber optic lines, you have networking inside facilities, right? This is a huge world. Even simply saying networking at this point can be a wee bit, fishy. It's not just simply about getting your CCNA anymore and going off for $100,000 a year job. Again, when you think about sysadmin work is completely different than networking work. Programming sysadmin work using, was it CloudFront, Ansible, Puppet, Chef? That's going to be an entirely different world than how I used to do sysadmin with right click, left click, that type of thing. Again, the difference between coding for smartphones versus coding for web applications versus doing other things. It's important to understand these are all entirely different fields, basically, that simply get lumped into this one name because most people, again, truly have no idea what the hell it is that we do. And so folks out there are like, computers. Again, that's why, like, I'm actually interested in programming now, to be honest with you, right? So if you go back 20 some odd years when I got my MCSE, I learned a little bit about programming. I learned C++ back in the day and Visual Basic. Visual Basic was actually pretty useful. But I basically stopped. I stopped because I didn't want to. Again, as an IT professional, most of my job was actually doing things that were other than technology. Like 25% of my job was sitting there tippy tapping at a screen. Then a lot of the job was communicating with end users, communicating with the executives, doing documentations, screaming at vendors, right? There's a lot of stuff. And so that's one of the things that I liked is I got to be technical. I got to deal with all this computer type stuff, but I also got to deal with humans too. I actually like humans, from a distance. Not too long, but I like them to be around. It's like cats. I never want to own a cat again. But if a cat sits on my lap, I'll pet it for a couple of minutes. That's kind of how I feel about humans, right? And so that's one of the things I loved about IT, right? I got to fly all over the country. Again, when work needed to be done, I actually had to fly. So I flew to Boston, I flew to Denver, I flew to, wherever it is, the offices that we had. We go in there, I meet different people, I do the work for the day. At the end of the day, I go and I, see the sites of wherever it was that it was at. And so it was great, as an IT professional back in, 2000 time frame. I got to do technical stuff, plus I got to talk to people, plus I got to travel. Plus I got to have great experiences. That was great. And I looked at coders back then. Again, you look at coders from about 2000. And what do they do, right? It was like the Matrix. Remember the first part of the Matrix? Imagine if your life was the first part of the Matrix, but nobody ever asked you if you wanted to eat any pills, right? You had little Neo, and he'd sit there at a computer screen, tippy-tap, tippy-tap-tap, tippy-tap-tap, tippy-tap, tippy-tap-tap, right? Because that was the thing. That was the thing if you go back to 2000. Again, we were still in the web 1.0 world at that time. So websites were very, very, very basic websites. Most of the coders out there were doing these very intensive type tasks where they basically sat there and just, typed out code on a computer screen. I remember going like right when iOS development became popular and a lot of the startups exploded. One of the things that was horrifying for me is when I would go in to just like the coder cattle farms, because like this was for like when the whole getting rid of cubes and all that was becoming popular, the open office space. And I swear you'd see these coders, man, and they would be at like these 3 feet desks. They'd have two screens, and then they were just side by side by side by side by side. They would just shove those jackasses in there. So even if they're making 150, 200 a year, who cared? They literally are sitting at these 3-foot desks with two screens, doing this far too much of the day. And that's why, again, I wasn't interested in programming back then, because balls to that, no. No, that sounds horrible. I had a friend of mine. She was a computer science major, and it was sad, right? She wanted to be a drama major and become an actress, but her father was a very strict person, and he was paying the bills. Remember, when your parents pay the bills, whoever pays your bills kind of sort of gets to decide what you do. So since he was paying her bills, he basically told her she had to go into computer science so that she could actually make a good living. Actresses don't make good money, unless you're whatever. Computer coders do. Anyways, when I knew her, and when I was getting my associate's degree, she was outgoing and vivacious, and just whatever, like one of those great people. Anyways, a couple years later, I went and she was getting her bachelor's degree in computer science, and she had worked her way up in the whole little academic system. Literally within a couple of years, she could barely string a whole sentence together. Like I met her, I was like, "Hey, how's it going?" And she took me into her office, and then she would start sentences, then not really stop the sentence. Just kind of, oh, I spent like an hour with her. It was so sad. It was so sad to see what computer science can do to some people. Is that what you want to have happen to your brain? That's what can happen in the real world, right? And I think that's one of the big things like a lot of people are just not thinking about. is like, what kind of a job do you want? Why I like programming now versus 20 years ago is, again, because of these APIs, because of where hardware has come and infrastructure has come. I actually look at coding nowadays very much like I looked at being a sysadmin 20 years ago, right? 20 years ago, you're doing configuration files and right clicks and left click. So again, so if I want to create a domain, right, I build the server many times. I install the operating system on the server. I set up Active Directory. I then spin up the client computers. I connect them to the domain. We connect them to Exchange server. We do VPN, whatever, right? Right? It's all these configurations and setup, right? Well, if you look at a lot of programming now, again, when I'm building these projects with Python or whatever else, right? I'm building the hardware of the project. I'm connecting that to APIs. I'm building other systems that also connect to APIs, creating rules to have the communication between the systems and the APIs. It actually looks a hell of a lot like sysadmin work did 20 years ago. And it's one of the things that I'm interested in with it, right? I'm actually dealing with hardware. I'm physically building things. I'm designing stuff. And again, in order to actually solve problems that I think that are interesting, I get to interact with people. I get to talk with vendors and that type of stuff. Again, it's a much different world than coding was 20 plus years ago. And so this is one of the things that you really need to be thinking about. And again, when I say computers, yes, it's a joke, but it's also a very serious joke. If literally, when you say you want to be a technology professional and somebody asks you what that means and you say computers, right? Not only should they laugh at you, but that also really means you don't understand our profession. And therefore, you also don't understand what is required for our profession. Again, whether it's math skills, whether it's interacting with people, what certifications you need, what programming languages you may need. Like these are, when we get hired based off of skill sets. Do you have the skills, or have you proved skills and ancillary things that should be able to be transferred over to the new work that you're going to be doing? That is the question that people are going to be asking. So you can have the best math grades in the world, but again, if you're designing iOS apps or something like that, it literally might not matter. People are going to be more interested in is what database systems, that type of thing, do you understand? And so this is something that you really need to take a look at. Again, that's one of the reasons why I do these one-on-one meetings here in Asheville. Again, if you sign up for one, is basically just to sit down with people and give them honest advice about how this world works. Again, you need to find mentors, good mentors. You need to find advisors. You need to do informational interviews. You need to go to meetups and simply talk with professionals and ask them what the hell they care about, right? Do people actually care about the things that you're learning? And, you might find out no. The answer is no. So there you go. There are some things to consider. Do you need to know math? For probably most of you, no. But for some of you, yes. Who's who? I don't know. I'm talking into a camera. I have no idea who the hell you are. So anyways, as always, I enjoy doing this particular video, and I hope to see you at the next one.